Hello, we are Group 14. I'm Ben Hinton, and I'm joined today by Peter Kroger and Joseph Gardner. And this is the Bicycle Information System.
So the agenda for our proposal today will start by going over the abstract for our proposal. Then we'll move into some of the background research that we did for this project. Next, we will move on to the design of the project, which includes the overall design, the hardware design, and the software design of it. Finally, we'll move into the Gantt chart, and then following that will be the budget, and finally the conclusion.
So this is our abstract. The goal of this project is to deliver a universal bicycle-mounted data collection and display system that users can attach to their bike. And we will be utilizing a PIC-Kit board with 28 pins and connecting external sensors in order to retrieve that information and display it to the user. And we will be doing this in real time via an LCD mounted on the handlebars. The goal of this is to keep the cost under $100 total, so it can be easily replicated.
And what we learned from doing background research on our project is that devices for tracking distance and speed on vehicles have been developed since the late 1890s, but modern cycling computers weren't in use until the early 1980s. So computers and GPS, especially with their modern capabilities, enhance these devices very much. And our goal with our bicycle information system was to be able to mimic these devices at a affordable price point.
So this is the overall design and the planned layout of our system. We will be connecting the Hall effect sensor onto the seat mount underneath the seat, and the magnet, which will pass by the Hall effect sensor on each rotation onto the rim of the bicycle and run a wire across the bike up to the front of it underneath the handlebars, where our black box will be installed with our microcontroller and our other wiring and housing for the sensitive components, with the LCD protruding from the top of it located on the handlebars, which can show the user the information it needs to. And then these three Wi-Fi symbol waves right here represent the Bluetooth connection, which will allow the user to retrieve the information and get it onto their smartphone so they can see how far they went and the speed they were going at.
So here's a block diagram of the specifics of the bicycle information system functionality. The system starts by having it turned on via the battery pack that will be installed onto the housing of the system. Following its initialization, we will interface with our microcontroller, which is our PIC16F886 microcontroller. Interface that with our Bluetooth in order to get the diameter of the bicycle wheel so that we can perform calculations on speed and distance using the Hall effect sensor. And this will be done as an input to Bluetooth via an app of some external device. Once that's all set up, the user can begin writing as the system is all set up. While they are writing, data will be output from the Hall effect sensor and the accelerometer to the LCD screen, displaying the speed and the current distance that they've traveled in this ride. Concluding their ride, this data will be collected and uploaded to our Bluetooth module and sent to an external device, either a phone or a computer, where it can be used for other statistics.
So for our hardware design, one of our main goals was to be able to achieve a runtime of 10 hours. And so to ensure that we were able to do that, we needed to calculate the power consumption for each individual component on the BIS. So I did that by going through each individual component's data sheet, finding the peak voltage and amperage for each device, and multiplying those two together to find the wattage, and then adding all of them up for each component. We got a total wattage consumption of just under 0.15 watts. And then we assumed 90% power efficiency, and we calculated that when using 4 AA Bauer degrees to power the system, we'd be able to power the system for 240 hours.
So for the software design of our project, we will be using the same IDE that we've been using in previous labs for this class, which is the MPLAB XC8, in order to compile the program and load it onto our PIC16F886 microcontroller. The inputs to our microcontroller in our system will be the Hall effect sensor data for distance and speed, the accelerometer for acceleration and speed, and finally the Bluetooth module input for the wheel diameter. The outputs of this will be to the LCD display, which will display the distance and speed calculated from the Hall effect sensor and from the accelerometer. And as well, we will be outputting data via the Bluetooth module to some external device.
So this is the Gantt chart we formulated when coming up with our project. And at first we started out with brainstorming, what area or sector could we add a microcontroller to improve a simple product, and we landed on a bicycle. Then as we've gone through, we've created a proposal, an invoice of components, ordered those components, and currently right now we're working on implementing the hardware in our system, hooking up the various components and sensors to our microcontroller and getting data out. And then after that, we need to work on the software, work out the kinks of our system, and then ultimately finalize this project.
So here you can see our budget for the total cost of the BIS. We broke it down for each individual component, and then we also assumed an extra 20% buffer to account for taxes and changing prices on each component. So our grand total was $64.50, and please note that this is for a one-off prototype version of the device, and if we were to mass produce this, it would be much cheaper.
So in conclusion, we plan on creating an information system adaptable to any bike, which will be able to display speed and distance on an LCD between the handlebars. This will also be built with resilient construction, meaning that it will be able to withstand some of the weathering and environmental things that can come on being on a bike. We also want to make this on time and within our budget of $100. And finally, we will build and test a program to fulfill all the needs of the system.
And these are the various references we looked at in order to formulate our project and our proposal and some of the background information. And that sums up our presentation. Thank you very much.